Davide. Thank you, Marco, for the introduction, and welcome everybody. So I'm gonna briefly introduce you this research line at NECSTLab called domain-specific computing. So briefly, who am I? As Marco said, I'm a postdoctoral researcher in the system architecture area, where I'm trying to focus on designing and co-design domain-specific architecture and systems. And moreover, I'm also doing several teaching activities in the field of computer architectures, reconfigurable system, and basic computer science. So, so far, if you have followed the whole flow, the traditional flow, you have understood that we have three research lines: IT for life science, domain-specific computing, and heterogeneous or high-performance computing. That will be the last research line. So I'm going to focus on DSC and briefly introduce you the context. So we are, you should be almost all familiar with this slide, which is basically saying that we are almost reaching the technological limitation of the current technology that we are using for general purpose computing architecture. And in this regard, there is a continuous tension between general purpose architecture and fixed function architecture that are striving to achieve the performance demand that is continuously growing and growing. So, however, since you cannot do almost everything or do only a few things, you can tailor your computation with the usage of domain-specific architecture, which are basically a way to tailor not to a single application, but to a broad domain of application. And in that regard, your domain-specific computation can have a lot of gains and benefits. The problem is that traditional domain-specific architectures, or DSAs, are mainly based on ASIC technology. This is a problem because not everybody can afford the time required to develop this kind of architecture, and that can somehow hinder your time to market or the capability to keep up with this algorithmic evolution. So that's why, for instance, here at NECSTLab, we are mainly tackling DSAs with the usage of reconfigurable system, with the so-called domain-specific reconfigurable architectures. We are trying to tailor our systems to the set of application, leveraging reconfigurable technologies. And this is, so what do we mean for domain-specific computing? There are several people currently in the research group, and we are tackling two main areas within DSC. On one hand, we are trying to build computer-aided design tools for building DSAs. And on the other hand, what we are trying to do is to focus on hardware-software framework, which means microarchitecture, programmability, for software programmable kind of architectures. And in this regard, example of the projects that you may find in this research line starts with SATL. So SATL is a prototyping, which is a library to build spatial templates for irregular application. I will not spoil many things because Francesco will give a talk about this specific research project. So please stay tuned if you're interested in knowing more. Then there is the hardware software framework for regular expression, where basically we are trying to see regular expression as a DSL, where we compile them into a set of binary instructions that feed and drive the software programmable core with different execution models that can be either depth first or breadth first. The other kind of project is the one that is focusing on bringing artificial intelligence from the dislocated cloud computing to embedded and edge devices, where in that sense we can have gains with latency and throughput stability and gain more privacy. Specifically, in this research kind of project is focusing on decision tree machine learning algorithm. And you will see that there are two main approaches. One that leverage reconfigurable compute logic to accelerate this kind of decision tree algorithms, which is N3. And then there is the other approach, which is Yozue, which mainly leverage over memory decision tree acceleration. And Alessandro will give you more details afterwards about the Yozue approach. Another kind of project is Faber, where we are trying to build image registration pipelines that leverage accelerators, both FPGAs on GPUs, and you can deploy them based on a set of customization parameter, and basically Faber outputs for you the whole accelerated image registration pipeline. Always following this path, there is Hephaestus, which is basically expanding what Faber can do and on target not only to the image registration, but also 3D image registration and achieve remarkable energy efficiency and speed up improvements. Last but not least, another kind of project is about design space exploration. Here, we are trying to target designers which are either willing to accelerate the manual development process, so more from an automation perspective, or would like to see how to find the Pareto dominance in their hardware architecture, which can be either through register transfer level or high-level synthesis kind of component. So this is a broad overview of DSC project. Today, we will have 5 different talks in the DSC area. The first one will be about automaton and regular expression from Filippo Carloni. Then Francesco Peverelli will dive into Sattler, which are spatial architectures templates for irregular application accelerator. Alessandro will dive into Yozue for decision tree ensemble acceleration. And then we will have Paolo, which will give us a talk about unleashing the performance of Versa system for 3D image transformation, while Giuseppe will conclude this session pushing this image transformation beyond simple FPGA limits, targeting bilinear interpolation. So that's basically all from my side for the DSC area. If you're interested, those are the summary of the talk. I will not wait further, and I will leave the stage to the first speaker,